Alright, welcome. If you're gearing up for your WAEC, JAMB, or NECO exams, you know the gas laws are a huge topic. So today, we're going to dive deep and break down everything you need to know to absolutely master this section with confidence. So here's our game plan. We'll kick things off with some real-world examples, then we'll get into the core theories and laws. After that, we'll apply it all to past exam questions and wrap up with a final checklist for success. So let's jump right in. First things first, why should you even care about this? Well, believe me, this stuff isn't just about formulas in a textbook. Let's see how these laws show up all around us. It's all about the properties of gases, yep. Understanding how gas pressure, volume, and temperature all play together is absolutely crucial, not just for a bunch of industries, but for you to pass a major part of your chemistry exams. Okay, to really get a grip on the gas laws, we have to start with the why. We need to understand the fundamental rule book that explains how all gases behave, and that's called the kinetic theory. It all boils down to this one powerful idea. Just picture billions of tiny invisible particles, molecules, just zipping around randomly at incredible speeds. Everything we are going to talk about from pressure to temperature all starts right here. Now, what's so cool about this slide is how these 5 simple rules explain so much. You know the pressure in a tire? That's literally just countless particles smacking against the inside walls. And the temperature? That's just a way of measuring how fast, on average, those particles are moving. It all connects. Alright, with that theory as our foundation, let's start grabbing our first set of tools. The simple gas laws. These are great because they show us how 2 properties of a gas are related when we keep everything else the same. First up, we've got Boyle's law. The easiest way to think about this is squeezing a balloon. As you squeeze it, you decrease the volume, right? And what happens? The pressure inside goes way up. That's an inverse relationship. If you double the pressure you're putting on a gas, you're going to cut its volume in half as long as that temperature stays constant. One goes up, the other comes down. Simple as that. Next is Charles' law. This explains why a football you leave out in the sun, it feels harder and bigger. When you heat up a gas, its particles start moving faster, they push outwards with more force, and that increases the volume. This time, it's a direct relationship. Okay, everybody, listen up. This right here, this might be the most important tip in this entire explainer. Seriously, write this down. All your gas law calculations have to use the absolute temperature scale, which is Kelvin. If they give you a number in Celsius, your very first step before you do anything else is to add 273. Forgetting this is probably the number one reason students lose marks. Don't let that be you. Alright, let's put Charles' law to the test with a question you might see on your exam. We have a starting volume of 100 cubic centimeters at 27 degrees Celsius, and we heat it up to 127 degrees Celsius. Our job, find that new volume. So let's walk through it. We start with our formula, V1 over T1 equals V2 over T2. We need to find V2, so we just rearrange the formula a little. Now we plug in the numbers, and this is the crucial part, we use the Kelvin temperatures, 400 and 300. A little bit of maths later, and boom, we get our final volume of 133.3 cubic centimeters, done. So the simple laws are great, but let's be real. In the real world, it's rare that only 2 things change. Often pressure, volume, and temperature are all changing at the same time. For those messy situations, we need the combined gas laws. Think of this one as your army knife for gas problems, the general gas law. It takes the relationships from Boyle's law, Charles' law, and another one called the pressure law, and mashes them all into one super powerful equation. If you see a problem where everything's changing, this is your formula. And now the big one, the ideal gas law. This is the ultimate equation, because it introduces this little letter n, which stands for the number of moles. That's the actual amount of gas you have. This lets us connect all these physical properties to actual chemical reactions. Super powerful. Okay, theory time is over. This is where the rubber meets the road. we are going to take everything we just covered and apply it to solve some real actual questions from past WAEC and JAMB papers. Here's our first challenge, pulled straight from a WAEC paper. It's a question that involves a gas. So what do they give us? The mass of magnesium. What are they asking for? The volume of hydrogen. And what's the key condition? It's at STP, standard temperature and pressure. That's a massive clue. Okay, here's the play-by-play. Step 1 is always to find the moles. We take the mass of magnesium, divide by its molar mass, and we get 0.25 moles. Step 2, we look at our balanced equation. See, it's a 1-to-1 ratio between magnesium and hydrogen. So 0.25 moles of magnesium will make 0.25 moles of hydrogen. Finally, because the question told us it's at STP, we can use that magic number, 22.4. We just multiply our moles by 22.4 and we get our final answer, 5.6 cubic decimeters. Now let's switch gears for a JAMB style question. Notice there are no numbers to calculate here. This is purely a test of your understanding of the core concept. So read that statement again carefully. Is it correct? Think back to Boyle's law. Absolutely not. This statement is totally wrong. It's describing a direct relationship, but we know from Boyle's law that pressure and volume are inversely proportional. Remember the seesaw. This is a classic JAMB trap. They flip the definition to see if you're really paying attention. So the lesson is, know your definitions code. Okay, we have covered a lot. Before we finish up, let's just boil everything down into a final checklist. These are the key things you absolutely must remember when you walk into that exam hall. This slide right here is your golden ticket. Temperature to Kelvin, always. Balance your equations before you do anything else. Know how WAEC and JAMB ask questions differently. For WAEC and NECO, you have to show your work every single step. For JAMB, it's all about speed and spotting those sneaky traps. Master these points and you are going to be in fantastic shape. So I leave you with one last thought to connect all of this back to the real world and your own safety. You've all seen the warning on an aerosol can, right? Do not leave in a hot car. Now you know why. Based on what we've learned, what do you think is happening to the pressure of the gas inside that can as the temperature skyrockets? Think about it. Thanks for watching, study smart, and good luck with your exams.